Okay, so before we start looking at the unit circle, even though we kind of started with that in class, we're going to look at the exact values. Let's get that down pat. The exact values are derived from using two special triangles. Those triangles can fit nicely into the unit circle. We could put them in there because, of course, they're 90-degree triangles, but we don't need to do that. We're just going to look at how we can find what exact values would be available to us if we wanted to know 30 degrees, 60 degrees, and 45 degrees. That is because when we start looking at more advanced maths, that is going to be nicer. You know, mathematically, we're always looking for the most beautiful looking formula, the most beautiful looking expression, and putting it in as nicely as we can. And to do that, we need to use the triangles. So let's have a look at 60 and 30. If I look at 60 or 30, it comes from half of an equilateral triangle. So if I was going to draw that, this is my equilateral triangle, right, cut in half. So that dotted line, of course, I don't know. The bottom angle here, of course, is going to be 60 degrees. Okay, and the top one, because it's halved from my equilateral triangle, is going to be 30. Okay, that's pretty straightforward. And if I want to then work out the other side lengths, it's a bit tricky because I'm not given anything. But in this special triangle, the base length is going to be 1 because it's now half of 2. And this length up here is going to be 2. This comes from being inside the unit circle, but we're not going to go into too much detail of that. So if we look at this, I have my 90 here. Then I can say, oh, well, there's a side length missing. How am I going to find that side length? If we labelled that x, we can look at that, finding that using Pythagoras' theorem. Pythagoras' theorem says that I can square the two shorter lengths and they will make the square of the longer length, which of course is your hypotenuse. So if I'm given the longer length, I need to do a subtraction in my Pythagoras. And we did that in year 9. So we're looking at x squared equals the 2 squared minus the 1 squared. Therefore, I've got x squared equals 2 squared is 4, 1 squared is 1. X is the square root of 4 minus 1, which of course is 3. I now have that in exact form. That's as exact as it's going to get because that square root of 3 is going to be a non-recurring infinite decimal or an irrational number. And if it's an irrational number, then we need to make sure that we leave it in exact form. The whole point of this is we're talking about exact values, okay? So that's for 30 and 60 to form the triangle. Then I look at it and go, well, I've got 3 really nice ratios for trig that we talk about. And those 3 ratios are applied to right angle triangles. And of course, sine of theta equals the opposite side over the hypotenuse. Cosine of theta equals the adjacent side over the hypotenuse. And tan of theta equals the opposite over the adjacent, right? If we remember all this, then we can look at our angles and go, well, what if I replaced this angle here for all of these? I'm going to replace with 30. So I'm going to go in and I'm going to do the 30. So 30, 30, 30. And if I'm going to do that, then I can replace the side lengths and look at, well, if I'm looking at 30, then 2 becomes the hypotenuse, always going to be. The x becomes the adjacent side, and the 1 becomes the opposite side. Then I go back up here and say, hang on, what's going on over here, right? I've got all these things which relate to these letters. So I go, well, O is going to be 1, so I'm going to erase that on this side. I'm just going to cross it out because my eraser is not working and go, well, that means when I've got the 30 there, this one's going to be 1 over 2. This one's going to be A is surd 3, so surd 3 over 2. And tan is going to be 1 over surd 3. As we talked about in class, we don't really like this to happen. Yeah, we want it to be to be rational on the bottom. So this is an irrational number. We want it to be a rational number. To do that, all I have to do is multiply this by the surd over itself. If I do that, I end up with, this is the same as multiplying by 1, because obviously surd 3 on 3 goes into itself once, multiplying by 1. But on the bottom, if you did your homework over the holidays, you would notice that when I multiply two surds together, I end up with surd 3 multiplied by surd 3 is the same as the square root of 9, which of course is just 3. So this now becomes surd 3, because 1 times surd 3 is of course just surd 3, over 3. And now it's going to be rational. And that is what you need to become familiar with, as opposed to this one. We're always looking for rational on the bottom. So we had this information on our triangle on the previous slide. So we ran out of room. So what am I going to do if I need to find it for for 60 degrees? Well, I'm going to do the same thing. I've got my sine of 60. I'm going to do cos of 60. And I'm going to do tan of 60, right? 3 different things. If I then need to find out those, I again go, well, I'm going to label this triangle. This is still the hypotenuse. Now that I'm using 60 degrees as my reference, the 1 is going to be the adjacent and the surd 3 is going to be the opposite. So I've got for sine 60, surd 3 on 2, cos 60, 1 over 2, and tan 60, surd 3 over 1, which of course is just surd 3. Don't have to do any rationalising here, which is nice, but you should notice that there is this nice relationship between sine and cosine. And as we talked about in class, there's that identity that you need to remember. So when you do your identity, when you look at the relationship, just remember that cos theta is equal to sine 90 take theta. Right? There's a nice relationship between 90 degrees for sine and cosine. Or likewise, I could write sine theta is going to be equal to cos 90 minus theta. Okay. If I then go through my 30 and 60, I've got all my answers. Now I need to find for 45. Okay, so that was exact values for 30 and 60 degrees. Now, the other one, which is nice and special, is 45 degrees. 45 degrees becomes from half a square. So if I was looking at 45, need the pen, degrees, we know that half a square, well, that's a right angle, and the top two angles are going to be both 45, because half of 90 is 45. And in the square, the side lengths are 1, again relating back to our unit circle. So we've got 1 and 1, and the one I don't know is this one here, which of course is my slice, and I don't know what that is. I'm going to label that y. In this one, y is the hypotenuse. That means if I went through and labelled, right, this one's always going to be the hypotenuse. I now want to find out if I can look at working out what the angle is going to be for 45 degrees. So if I went for 45 degrees, I could say, well, of course, remembering our sine, cosine, tangent, if I've got sine of 45 degrees, really, does it matter if I choose this angle or this angle? No, because they're exactly the same. So because they're exactly the same, I can simply go, oh, well, I'm going to pretend that I'm using this one here, and I'm going to make this side length the adjacent and this one the opposite. If I'm doing that, then I can say, well, for this one, for 45, sine 45 is going to equal 1 over y, but I don't know what, 1 over y, but I don't know what y is. So I need to find y first. Of course, we use our Pythagoras. Pythagoras says that y squared equals 1 squared plus 1 squared. 1 squared is 2. So I have, 1 squared is 1. 1 squared plus 1 squared is 2. So I have y equals the square root of 2. So I can just put that in over here. That's surd 2. So then when I fill in my ratio here at the bottom, I can say sine 45 is going to be 1 over surd 2. And since the denominator becomes irrational, I want to make it rational, and to do that I'm just going to make it surd 2 on 2, just using the method we talked about earlier. I can say the same thing about cosine of 45, 1 on surd 2 if I'm looking at my triangle, which of course is surd 2 on 2. And if I was talking about tangent, well, tangent of 45, I'm using the two given side lengths that I had, which is 1 and 1. That's 1 over 1, which of course is just 1. So I now have my exact angles for 45 degrees. So we can summarize our knowledge of exact values into a really nice table. We can then memorize the table or learn the triangles so that whenever we need to use our exact values, we know exactly where we need to go. More than likely, we're going to need to know our exact values when we're using our tech-free exams, which means that we won't have a theory book or a calculator. So if I'm going to go through and do that, a nice table to line up is you always have theta here at the top. We're looking at 30, 60, sorry, I'm going to put 45 there instead, in the middle. 30, 45, and 60. And down the left, we're going to have sine and cosine and tangent. So cosine of 30, we know, is a half. Sine of 45 is surd 2 on 2. Sine of 60 is surd 3 on 2. And remember, there's that nice relationship between sine and cosine, so we can say, cos of 60 was half because of that relationship. Cos of 30 must be surd 3 on 2. And 45, going to be the same for both, so surd 2 on 2. Then we go back and we look at tan. Tangent actually is a relationship between sine and cosine. And we'll see that more when we look at the unit circle. But remember I said to you that tan theta equals sine theta on cos theta. That is another trig identity. So I could use my 2 bits of cosine, right, when theta is the same for all three. So my 2 bits of sine and cosine when theta is the same for all three to find tan if I can't remember them. But a good way of thinking of tan is when I look for 30, it's my surd 3 on 3. For 45, it's going to be 1. For 60, it's just going to be surd 3. And now we have our nice exact values table, and we've looked at the 3 identities. I'm going to put a different video up looking at our unit circle and radians.